Yeah, I'm using another video where first my internet got a problem, so therefore I'm continuing with step 3. In step 3 is here we need to start the timer using tcon register. Tcon register, the d4 bit d4 will be there. Bit d4, this is the d4th bit of tcon register, and this is t or not t or 0, and d5 bit is d t timer flag 0. These two bits are important. This bit is used to start the timer, start the timer, and this bit is used clear the timer flag bit for a next count. For next round of iterations, we need to clear the the uh, keep checking the timer flag and timer say stop the timer flag and clear the timer flag for a next round of iterations. We need to check each and every time this whether this timer flag will be 1 or 0. Next, to set this timer, to set T or not, directly we can use this instruction B set B tcon dot 4. See this, these two bits are bit addressable. Bit address tcon is a bit addressable register. So each and every single bit also we can address. So tcon 0.4 means the d4th bit of tcon register will become set. And step 4 is, in step 4, stop the timer. Stop the timer. So that is T or not should be equal to 0, and this can be written like this: clear T or not or var, or we can also write like this as clear tcon dot 4. To start the timer, we should make one set, and that is T or not is equal to 1. To stop the timer, we need to make this one. And next, in step 5, what happened in step 5? Clear the timer flag bit. In step 5, clear the flag bit or timer flag bit which is equal to tf naught. So clear means how to clear. This is tf naught is a d5 bit, so clear tcon dot 5. And in step 6, we need to load the count register. Again, see, this is to repeat another, to repeat same process. So again we need to load the load count in th0, th and tl registers. And next, now we'll see the ALP program, assembly language program. ALP program to generate 5 milliseconds delay using timer 1 mode 1. So already we calculated in step 1, that is t mod value should be 10h. So therefore, yeah, we can write one instruction, write a ALP program, move t mod register as immediate data 10h is loaded in. Now by this, the timer will come to know, and we in a timer 1 and which mode and which timer. And next, we also calculated this count value th0. Sorry, here move th0 comma hash hash, sorry, timer 1, right? This is timer 1, th1 hash, this is EEH to generate 5 milliseconds delay, and move THTL1, which is as 00H. Here letter is start, should not start with the letter, should start with number, so therefore we need to add 0. And after that, in step 3, start timer. To make a start timer, we need to set B tcon dot 4 timer set, and every time we look for we have to look for a flag bit. So therefore I'll write one J and B, jump on no bit tcon dot 5. Tcon dot 5 means this is TF naught, TF1, TF naught. So therefore this jumps to L location. So here itself, until a TF jump on no bit to N. If it is 1, it jumps, it comes down to here. After that, once it becomes 1, so therefore timer overflow flag will set to 1. Means this EE and 00 all total is decremented and reaches to 1. So therefore timer overflow will become 1. So we need to stop the timer. So to stop the timer, we have to write a clear tcon dot 4. And to make another here TF naught will become 1 by this case. Again we need to clear TF1. So that is tcon dot 5, tcon register 5th bit. So therefore next, to stop the program, sjump exit will be written here, exit. Otherwise, if you want to repeat further, so instead of sjump exist, we read sjump repeat, and this repeat line should be connected here. This one, repeat label will be assigned to th1 and tl1, and this particular program generates 5 milliseconds delay using timer 1. Okay. Next, I'll write another program which generates. I'll write another simple program. Here, write an ALP for 10 milliseconds delay using timer 0 in mode 1. Here the solution is step 1, when we need to tmod register. So we need to find the tmod values and which values. So here tmod, here timer 0 means first 4 bits, 1 2 3 4. This is m0, m1, c by t bar, and this is gate. Gate is 1, timer is also 1. In mode 1, this is 0 1. So these remaining these bits are don't care, and don't care. 4 bits are don't care. So therefore we can use 0 0 0. This is timer. This is for timer 0, and this is for timer 1, T1, and this is for timer 0. So therefore 01H, sorry, 01H to be loaded to tmod registers. In step 2, count value. So we need to initialize the TL0 and TH0. For that we need to find an initial count. To get initial count, we have a one formula is there, which is very important. that formula initially I wrote. So this is also another formula we can write like this. The delay. The delay. How much delay? Here it is 10 milliseconds delay. Here the 10 milliseconds delay. Delay is equal to maximum value. This is f why, because 16-bit counter mode 1 minus count into timer per 1 clock pulse times for 1 clock cycle. Here the given delay is, this given delay is 10 milliseconds. 10 milliseconds is equal to, I'll write in 65 by 36 minus count into 1 timer for 1 clock cycle is equal to 1 point. This is here timer clock frequency is equal to crystal frequency divided by 12, which gives the frequency, and the time is equal to 1 by frequency, that gives a 1.085 microseconds. And so from this only one variable is the count. So if I write a count value, it becomes 56,319. If you convert into hexadecimal numbers, this becomes dB FFH, this value. So therefore TL0 is equal to FFH and TH0 is equal to dBH. In third step is, in step 3, start the timer. Start the timer. So TCON register bit for D4 bit. So we need to set. So by writing set B TCON dot 4. Then after that, stop. If you want to stop timer, this D4 should become 0. So therefore clear TCON dot 4. This is for start the timer, and this is for stop the timer. And fourth one is clear flag bit. Clear timer flag for next round. And next, fifth one, load count register. That is TL0, TH0. TL0, TH0. Now I'll write a program. These are the five major steps for any programs, delay programs. ALP, assembly language program, to generate 10 milliseconds using timer 0. This is first tmod registers. Move tmod immediate data 01H. Why? Because we are using timer 0 and mode 1. So therefore again move, we calculated a count value. This is TH0 initial. This is 0. Sorry, this is 0 dBH. Next, lower count value. This is TL0 as 0 FFH. Next, we need to start the timer. That is set B TCON dot 4. And this is T or not will become 1, which makes starts the timer. Starts the timer. And next, we need to check every time. We need to check the timer overflow flag. So TF not. So therefore, J and B jump on no bit, A bit, T-con bit. T-con లో fifth bit. ఈ fifth bit అయిందనుకో జంప్ టు ఎక్కడికి L1 means loop 1. Loop 1. Here is a label address loop 1 here itself. Here what happens is TF naught is equal to 1 means overflow flag, timer flag. And timer flag 1 indicates that if it is 1, total time while count value is counted. Why? Because from 0 dB to FFH total, this value is decremented. Then only this tcon dot 5, that is TF naught, will become 1. So after checking, next we need to, if it is 1, if it is not 1, then loop continuously it loops until it decrements all these count values. If it is 1, then we need to stop the timer. So clear, to stop the timer, clear tcon dot 4. And we need to make, we need to clear timer flag also. So therefore clear tcon dot 5. Tcon dot 5. And we created here, and next we need to stop s jump here itself. This is unconditional jumping instruction here itself. So this moves continuously, jumps, and it creates infinite loop. So it becomes off, stop here only. So if you want to report total again after 5 milliseconds, again 5 milliseconds, instead of right here s jump repeat, and this repeat address should be given to the label address should be given to the this one here. This is a repeat label. By this continuously it rotates like this, rotates like this, rotating like this, rotates like this, and we can create as delay as we want. We create as delay as we want, we require. So this is all about a timer delay program. The only basic steps are, first we need to calculate a T-mod value, and next count value, next to start the timer, next we need to check whether the timer flag bit is 1 or not. If it is 1, we need to clear, we need to stop the timer. If it is stop the timer and timer overflow flag became 1. So if you want to use again timer 0, so we need to clear TF0 bit. So that's why clear T1.5. These are the 5 most important steps for writing any program using this T-mod registers. Thank you so much.